Don't know, my name is Kegel. I work remote for a company out of Austin called Vast. Check out vast.com if you want to see what we do. For the most part, I actually work these days as a data engineer, so I get to be one of the lucky guys that takes the crap code that our data scientists produce and gets to put that into production. It's actually probably the coolest job I've ever done, and if you guys want to hear more about it, I'd love to tell you. So I think now let's dig in for the reason that you guys are here.
The crap code's primarily in Python, correct?
Yes.
So
it is.
You left out the hardest part, which is you take their crap Python code and turn it into Scala.
Although it hasn't been Python in a while, fortunately.
Talking on Python.
Oh no.
On Python.
No, it's not the Python. See, Python's a good language. There are people who are attracted to Python, and most of them are not good software
They're
engineers.
attracted to plugins.
Well, I mean, the languages, well, let's leave that.
Yeah, exactly.
Let's actually talk about the reason that you guys showed up. So tonight I'm going to be talking about decompiling all of the bits of Scala so that we can figure out why it works the way that it does. Because one of the things that we have to do at Vast is about half of our code is Java and the other half is Scala. Now Scala is a lovely language when Scala is calling off into Java land, because things just work. And they work the way that you would expect, and the syntax is all basically the same. But none of that is really true when you're going from Java back into Scala. You now have to dig in and understand all of the magic that Scala is doing in order to basically get things to go both ways. So that's really what we're going to be doing here is putting together the basic constructs of a Scala program and decompiling. So these are the constructions that I could think of. If anybody thinks of any that I don't have on this list, please add them. And we're going to go through in sort of a basic order. So I put together roughly 7 different modules that we can go through and compile and then decompile. So before we get into doing that, I wanted to show you some of the tools that I've been using to do that. If you haven't used either of these before, don't worry about it. They were sort of the 2 stable decompilers that I found, and they're actually based on each other. So let me bring up JD GUI, which is the Java decompiler GUI. You'll find it on jd.benow.ca. And as far as I can tell, it's the most fully featured Java decompiler out there. It will actually take your JVM bytecode and more or less reasonably turn it back into readable Java. And so we won't actually have to look at JVM bytecode instructions tonight for the most part. We will be able to, if and when we have to, but for the most part it'll be readable Java. Well, I say readable, but there's going to be all kinds of crazy stuff going underneath. The other really good decompiler that's out there is Bytecode Viewer. Their website is bytecodeviewer.com. They actually use underneath JD GUI to power a lot of their decompilation. But the thing is, there's actually like 7, well, maybe not 7. I think there's 5 major decompilers out there. They bring in all of them. So you can actually choose which decompiler you want to use. I think the reason for that is often the Android ecosystem, it's sometimes necessary to see what your Java jar is being compiled to into Dalvik madness. So for the most part, you should never have to do this, but it's good to see what your Scala is being turned into. So let's just start with a basic hello world. So this is our app. It looks a little bit, yeah, I can definitely do that. Does that help?
Okay, thanks. Yeah, that's good.
Well, I mean, don't keep the camera on me. Keep it on
up
there.
Yeah.
So, all right.
Thank you.
Okay. So, for those of you not familiar with, Scala, this is going to Scala has things called objects. Objects are a first-class singleton type to Java, effectively. So what this code will do, after we compile it, we can look at the artifacts that get created. This, unlike Java, we've got 3 artifacts now. That's a little bit crazy. So we're already deviating really far from the Java ecosystem in that our one .scala file produced many classes, so it's one to many. So let's execute this, see what happens. So we get hello world twice. That makes sense because we're printing twice. And the first time we're printing this, which already looks different in that this is a curried function. And then we're printing this, which is using default arguments. So this isn't by any means the simplest possible program that we could look at and decompile, but it does bring in a lot of the things that we care about. Mostly like how are functions and objects being represented, because every program will start with object extends app. That's just how it's going to work in the Scala ecosystem. So this is something that, when you first start off, you need to see it. So the decompiler that I'm going to prefer tonight, and if it doesn't work, we will choose something else, is bytecode viewer. So let's see if I can get this to work. Yes, I think I can. All right. So we see that there are 3 different classes that got compiled. There's main dollar, and there's main dollar delayed init body. Okay, so what horrible stuff did the Scala compiler just go and do to our beautiful, beautiful code? This is hard to read even for me. So let's see if JD GUI is better. Okay, I don't think, well,
There should be a way to have the Mac zoom in.
here we go.
Oh, we can do that.
I knew that JD GUI was going to be better, I just didn't know how.
Yay.
Because personally, I don't use bytecode viewer, I actually use JD GUI itself. So, all right, so anybody who thinks this is readable is probably insane. But there's lots of random crap in here that it's not obvious why it should be here. So here's some Scala imports. We sort of understand why that's going to happen. Here's Scala's signature. Why does Scala need to have an annotation? Well, we'll get to that in a little while. Here's something that finally looks like a Java equivalent main method. And what is this doing? This is punting on the work that it would normally want to be doing. So where is that? What is that doing? We now have app class main. So the first thing that this is telling us about our beautiful transition from Scala into Java is that the very first thing that our app is doing is not executing our code, it's jumping back into the Scala runtime to do stuff. And if you've gone through any of the tutorials about how objects work, you're allowed, unlike in Java, to execute expressions in the body of classes and traits and objects. Well, how's that going to work? My guess is that this is how. And this is actually where the whole delayed init fiasco comes from, in that this will eventually then call back down into the body of our function. So let's go see if we can find a thing that looks like the code that we actually wrote. And this looks like it's it right here. So this synthetic method is what is actually calling our print lines. But it's not system.out.println. It's a print line that exists in the Scala predef. So the predef is what Scala brings in for every .scala file that you compile, and it has all of the type annotations and other functions that you're normally going to use. It brings those into scope. So who wants to type system.out.println? That's just a hassle, so Scala makes it simpler. There's just println as a function that's always in scope. Same with list. List is a type alias that lives in predef, And then it actually refers off to like Scala collections and your list.
Any idea why there's a double dot? Dot, dot?
So this is where Scala is doing magic. I think to make predef a symbol name that can't be used. Because normally you can't have dots in the names of packages, right?
Right, yes.
Because things would just get totally screwy. So I think what they're doing, the JVM itself doesn't have that limitation. So that's what they're doing.
Illegal, I
It would be
see.
illegal to import predef yourself.
Got it.
I think that's what's going on.
So is that the same rule for main up above? Because they did main double dot as well.
It was in the main class.
Right here?
Oh, yeah.
Yep, right there.
Yeah, that might be.
Yep, okay, interesting.
That's probably what
So-
they're doing.
And that's to suppress importing main at that point.
Probably.
Interesting, okay, cool.
Yeah.
Just wanted to feel for what the intent was.
Does the underline in this tool imply you can click on it?
Yeah, as far as
So
I can tell.
what happens if you click on the main dot?
This,
No, to
Oh, that one there,
Yeah.
yeah.
It goes to main dollar. I think the dots and dollars are,
Interchangeable?
no, I think this thing is, I think it's actually rendering as dot what is actually dollar in the class files, which I think is going to end up being confusing.
Okay.
Dot just denotes the packaging. I mean, dot just is the packaging. The dollar is just a valid literal. I mean,
Well, but dollar is not a valid literal.
so
No. It's their escape character, which is why dollar gets used, well, we will see lots of interesting uses of dollar.
It's like underscore. It's like
Yeah.
all over the place, okay.
Yeah. So, what have we got here? So we finally know. Oh, right here. We jumped up into main dollar, which is this other thing. So now all of a sudden our app actually, or our main object, has two class files associated with it. So main.class, this is all the static methods of the class. And then this gets instantiated, I think, right here, or not right here, but at some point down right here, as your singleton, basically. So this is how objects get turned into classes. The actual instance of your object, like if you needed to call a method back in, depending on how the linkage was working, you actually need to, from Java that is, you actually need to be referring to this module dollar object. It's really weird. I've had to do this a couple of times because this is how they're able to have objects that extend classes and implement traits. Because a static method really is just a function on the JVM. So you have to, if you're going to have any of those virtual lookups, the vtable, you have to instantiate a class at some point. But in order to make everything work right, they generate a synthetic class called foo$, and then instantiate that off here, which I think gets instantiated when everything loads. So like this is the private constructor, which I think is called, yeah, right here down by static.
Oh, got it.
So
There.
when the class loader loads everything here, it's going to call this, which is going to instantiate your module dollar and set everything up. So does that make sense for folks? Shake your head, raise your hand.
So that, and the order of instantiation then would be, if you attempt to instantiate some other class, it initializes the object analog, and then once the object analog is in place, then you can begin to generate instances of your actual class itself on the
Well,
Scala
you're never
side.
going to, this prevents you from instantiating your object, because it's a private constructor, right? Scala generated all of this code for you.
But this is class loaded as a result of you referencing the class, the object,
Right,
correct?
right. I mean, if it's on the
Okay.
class path and imported, it'll be
Okay.
brought in and instantiated. So-
Wow, this is really like, yeah, it's
But that tells you
intertwined.
that your objects don't exist as real objects until they're imported, until the class loader knows about them. Which,
Yeah, makes sense.
okay, that's
because-
kind of funky. So, yes.
What is the new doing without a class name to the right?
Static.
It's new, it's itself, it's knowing
Okay.
itself, isn't
Yes.
it?
Well, I don't know that that's valid Java, but as far as I know, that's going to be newing inside of this class, which is going to be calling out to this private method right here. So there's only one constructor in this class. This is it. It's private, but because the static block is in there, it now has permission rights to see it.
But he's saying new and open parentheses,
Well,
there's no reference to main in
No,
front
I
of
was
parentheses.
confused. I thought we were looking at Java
That
code.
might just be the decompiler not knowing what the hell to reference in
Oh,
in
okay.
that case. So I don't claim that these decompilers are going to be perfect in rendering Java code. In fact, a lot of what Scala does can't really be rendered into Java. So these tools are just doing the best that they can.
But they can be rendered into something that will run on the JVM.
Exactly. Okay, so let's look a bit at our method down here. So, okay, so Scala is helping us out by giving us a static reference to print line that's up in the predef module itself. So predef is already an object and has some of this magic going on. What's the first thing that we see about these methods that we're calling? Well, the interesting thing is that greeting and place down here are now functions, whereas in here, when we were calling this, greeting and place are defs. So this is fine, except what it's telling us is that we can have no arg or parameterless methods off in Scala. So if you haven't seen that, you can do that in Scala. So this gets translated into code that very much feels like we know what it's doing. Like, except for the fact that it's a curried method and we have multiple sets of parentheses here, we could imagine writing this in Java. So Scala allows you to write curried parameter lists. Unlike Haskell, it's not fully curried, so you can have just n arguments and then curry them together. You actually have to specify which groupings you're going to allow. So in this method, what we say is the first string and the second string, let's just pull them apart. Well, how are we representing that on the JVM? What does that look like? We're going to close this guy so I don't get confused. It looks like a method of 2 arguments. So all of a sudden, Scala's lying to us. Scala told us that we had a method of 2 arguments, but it was curried. Now it's telling the JVM it's got a method of 2 arguments, but it's not curried. So this is sort of the first place where if you need to call into a curried method from Java, or you don't have to worry about it. You can just pass in all the arguments and it'll just
So if there's like an order of operations, like with the curry, you go what, left to right or right to left? The first one would evaluate
Be
the
left
second
to right,
one. In this, it flips it.
no, it shouldn't be.
Or is greeting, because greeting would evaluate first, and place would evaluate.
Yeah.
And then they would, now in your Scala code though, isn't it backwards?
I don't think so.
Doesn't
No, it's
place
greeting
evaluate
place.
first
It's
and then
greeting.
greeting evaluate?
No, not as far as
Oh, okay. I thought place evaluated and then was passed into greeting, and it was passed into.
That might be the case. I don't think so. Except I think the semantics of the JVM prevent any issues from happening. And you don't have like post-decrement or pre-increment or anything like that. So you don't generally have to worry about those kinds of issues. So the fun one comes with make greeting. So what does make greeting look like over here? Well, we're not passing anything in, but it is a method that takes stuff. Well, this isn't something that has any analog at all on Java. Like, you have to provide arguments all the time. So what does this look like in our compiled code? Looks like this. The compiler went and found something that's named really, really weird. So it generated a synthetic function to go call. And then it stuffed those in place, and now it's calling our make greeting. So what does this guy actually call? So it's a synthetic method that then knows how to call greeting. Well, isn't that lovely? So already the Scala compiler is doing all kinds of weird magic in the background to make things work. So that's curried methods, that's sort of functions in general, that's objects and what they're doing. Let's look a bit at what this guy is doing over here. What is delayed init body doing? By the way, this is the first time that I've looked at a lot of this code, so if I'm as confused as I sound, I am. All right, so this is where our apply method is being instantiated, or somebody's apply method is being instantiated. Not really sure what's going on there. Oh, this is the infamous outer. Okay. So this is where our method body is actually being called from. So this is where the whole delayed init thing comes back into play. So I'm pretty sure that after, like, I don't know if it's so many milliseconds or just what actually kicks it off, but the whole thing about app is that it relies on this mechanism to at some point come back around from the Scala runtime and basically drop into one of these methods, probably apply at some point, because the Scala runtime knows about it, and then it actually starts executing your code. Let's see if we can find it from main, because that's where our main method exists.
Oh, there it is at the bottom, right, isn't it? Oh, gone.
Well, it's this right here. Yeah, I don't know. So what's some other fun code that we can look at here?
Oh,
I'm thinking that Greek place looks really interesting as far as code goes. So what is this doing? What does Greek place do over here? So this is string interpolation. And what it's going to do is just stuff the first parameter right here doing a toString, the second one right here doing a toString, and then just construct a string. So what we should end up with is hello world bang at the end, because, well, that's what we're passing. So over here we see our two parameters, and they're actually named the same thing. So Scala is preserving our parameter names, which is really good. So we're generating a new string context, or string context. String context is pretty different. We're generating an array for empty string, space, and bang.
Those are I think those are the string fragments around
Yeah.
Yeah, which is
They
what
are.
I was
variables that
gonna
are
say.
going
Yep.
to be replaced. Yeah.
And then we do a generic wrap array
GMP, and then we fold them
of,
together.
oh, right, so we're gonna fold this, then that, then this, then that, then this. Okay, that's really complicated. I had no idea that was how this worked.
I think I remember reading about the use of the what they called interpreted, not interpreted, where you can use the dollar variable inside those special. Is that
Oh,
The string
interpolated.
formatting.
Two dot-
String
2.10? When did that come?
Oh, yeah, that was, it was
211.
Was it
211
211?
introduced this.
211?
Yeah, it was
Yeah.
not that long ago.
And,
Yep.
and I remember reading some articles on basically how they would implement it. And what I remember is looked like what that code would be, right?
Yep.
So
So if we want to understand, like, why Scala does so damn much object allocation, now I think we know why. All right, so what's some other interesting code?
It's funny, we're looking at it right now. When 212 drops, you realize a bunch of this changes, right?
We're going to get into what changes a little bit.
Okay.
I don't think any of this changes, because I don't think any of this can. Like, everything that's synthetic in here has to stay here.
Yeah.
All the
I see.
212 stuff with Java 8 is around traits and default methods and interfaces.
Okay.
So, It might be that they can, I know that they want to get rid of delayed init.
Yeah, that's
some of
what,
that's-
right, that was the last thing I read, or most recent thing I read.
So I have no idea how that's going to work in the future. I'm still really confused as to how.
Well, what's this app dot class? Where did app dot come from?
Oh, it knows about that. Oh, well, app comes from
That's
this.
just
We,
all app.
we extended it.
Oh, yeah.
So we're implementing that.
Got it, and that's actually a Java, then that's a Java something.
It's actually a trait.
Well, you should
It's a
drill
Scala
into
trait.
app because it hides main, basically.
It does, yeah.
Well, but I'm on the Java side, where you're looking in the decompiler, app's gotta be a Java something. You're now no longer in Scala context. So is it in pre-dev? Is it something that's all included? In other words, what's app's context? There we go. Okay, that's what I'm looking for.
And I have no idea how that works.
Okay, so they have a Scala class, they've got a Java class called Scala.app that they include.
Yeah.
Okay, okay.
All right, any questions about what's going on before we move on?
So does the app class take basically anything that's in the body of the object and run it?
Yeah, that's exactly what it does, actually.
Yeah.
So that's its entire point, is that the body of the object becomes your new main method. So, but then all of this machinery is what generates to make that magic true. All right.
I think that actually makes this scenario more complicated than just what Scala does to a plain Java class that doesn't extend from that.
Yes, that's very true.
Yeah, there's a lot of like scaffolding to make that run.
Yeah.
So let's look at what var and valor turned into. Have that. Let's just cap this. So we're going to take a look at a case class and then a simple class right here. And let's make this a little bit more interesting by making this a var. And we'll make, I put all of these samples together in like an hour last night. So if you guys want to see more complicated stuff or even simpler stuff, just tell me and we'll do it.
Yeah, I'd be curious, not right this second, but for you to do a function that's curried where the second parameter list refers to one of the parameters in the first parameter list.
So that default then I think is just going to reference the other default is how it works.
But how does it show up into the
So if you had default 1 and default 2, right? Default 2 would just reference default 1. And then default 1 would go back to whatever it was that you actually were pulling in.
Okay.
I think that's why they generate the synthetic stuff, so that everybody can reference everybody else in there.
So wouldn't it have to generate two functions at that point, though?
Well, but yeah, it has to. It's still going to generate default 1 and default 2 because we saw.
Oh, those are
generate.
functions. I got it.
Yeah.
I got you now. Okay.
Okay. What am I doing? All right. So let's. All right. So let's go look at that code again and see what he's doing. So he declares a.
Okay, the new version.
Or, yeah. All right, so he declares a case class foo. So we're finally going to get to look into what a case class actually is. And we declare a regular class bar that uses the odd constructor syntax that Scala brings in, which is this stuff up here. And then we do a little bit of stuff down here. We declare a var down here and up here. And then we declare a lazy val. So this is like, again, way more Scala constructs that don't exist in Java. Let's go see how they're implemented. So let's look at bar first, because I think that'll give us a better idea of like, that translation shouldn't be all that complicated. Like really, how much bad can the Scala compiler do to make a simple class work? Well, a lot as it turns out. So like, bar over here isn't that much. It has like 5 things. Over here, it has a lot of things.
You know, that lazy value is definitely, it's probably the largest, isn't it? The largest in-
Yeah. Yeah.
Yes, injection, yep, there it is.
Okay. So the first thing that we should notice is, again, we're seeing Scala signature. So this is where we might want to jump ahead. What is Scala signature? Why is it necessary, and why is it even there? Well, it turns out that the Scala type system is slightly different than the Java type system. And the way that they implement a lot of their stuff, especially Scala reflection, it's actually all of Scala reflection that relies on the Scala signature. They take, as far as I know, their entire AST and encode it bitwise into the Scala signature, so that then when you reflect at runtime using Scala reflection, which is not Java reflection, you can get back that AST. As far as I know in Donnie, a lot of that stuff is changing and going away, or at least some of it's going away. I know that the reflection-based macros are going away, which what that is actually going to mean, I don't really know. But this, and as far as Tasty goes, Tasty might be using the same mechanism and just encoding entirely different data. So, but if you have a class that doesn't have a Scala signature, and you try and link to it as Scala, your compilation will fail, because the Scala compiler is looking for this stuff. So, all right, so we had 5 different variables that we declared.
It's a cross check too. It's almost a parity check. I'll bet if you
Yeah.
also left that Scala annotation and you went in and you added a method or a local var, I bet the compiler would eject it when it attempted to, I'm sorry, the runtime would eject it when the class loaded.
It might do that, or your compilation might not be able to do certain things. So like with an object, this is probably how it does object.type, and it knows that you're referencing an object type. Or the variance annotations and gets those right.
Okay.
That's what I
I
imagine.
wonder if they're
is
trying to,
happening.
I was wondering if they were trying to stop patching it after it's been compiled but before it's been executed.
Well, I mean, it has to be able to import a class that doesn't have that indentation, right? That's just going to be a regular Java class.
Yeah.
So, but what's going to be the difference is like what you can do in the Scala code against that class.
Okay.
So we have A, and over here A is an int. But one of the things to keep in mind is that Scala doesn't have primitive types the same way that Java does. So what is our big int over here being translated into? Well, we can see that we're actually translating it into a primitive type, so that we know that the Scala compiler is smart enough to be good about this, thank God. It's not boxing all of our primitives. But what do we see that's interesting here? So one of the things that you might remember from Scala is that methods and variables all inhabit the same namespace. So you can't have a val A and a def A in the same class, because those refer to the same thing. Now, there have been bugs around this, and actually one recently got posed where you can actually have collisions. Thank God they're fixing that. But that's not true in Java. In Java, your fields inhabit a different namespace than your methods. So, like over here, we literally have a field named A and a method named A. That's because you can do that in Java. But the thing is, in Scala, all of our getters are going to be calling our getters. So the Scala compiler is generating basically a getter and a setter for every var that we have. Because this is a var, which means that we can modify it. B doesn't have that. So you have no avenue to go set that method, or that field, which is nice. So it's auto-generating. Now we knew that from our vars and vals, but now we can see how it's implemented. And of course there's $equals, so there's all kinds of weird